Second video. Now we're gonna go over bearings and point of beginning. Um, Again, I'm gonna touch on it briefly. In other classes, you're gonna go more in depth, but I don't want to take too much time on that. But bearings very important. You need to know what are the actually. Let me show you again. I think I still have it on here. The bearings, what they are the length or the size and the direction of the piece of property you have. For example, I'm going to bring the plat back and I'm going to zoom in there. And in the bearing, you're gonna find this. You're gonna find some numbers with with letters. Okay, for example, this one. Let's look at lot 24. It's south 88 degrees 9 minutes 29 seconds east. Okay, this side here again. This is the H proper, right? You can see right there with datums. Okay, so and then this line of the property, it's north 0 degrees 14 minutes and 6 seconds. So whenever you see, of course, the little circle, that's degrees, one line after the number, that's minutes, two lines, that's seconds. So it's degrees, minutes, and seconds. Now the first letter is where it's starting, and this one where's this angle going to. So in case this one, and we're going to talk about point of beginning. From the point of beginning is going to go south 88 degrees 9 minutes 29 seconds east. Okay, and if it's not making sense, just I'm going to show you something right now. So those are the bearings. Okay, and then it tells the size. So this one is 110.04 feet, and that's the direction of this line here, which is this property line. This is the direction, and this is the size of that, the length of that. All right, and then we'll talk about this ahorita in a bit. So again, this is the angle, and this is the length, the direction and length. Okay, now based on that, let me show you this now. I think I have it somewhere here. You see it on your book on page 27, but just for the purpose of the video, I want to show it to you too, which is this part here. Let me move it in. There we go. This right here. This is how you read it. Okay? All of us know that we have north, south, east, and west. Okay? Remember those angles that let me bring it back. Those angles that I was showing you. Did I close it? No, right here. There we go. See right here, it says south 88, blah, blah, blah. It says north, whatever. It says north, it says south, and each one of them has its own. South 48 degrees, 6 minutes, 52 seconds west. Okay? So notice that all these numbers, they either start with S, and maybe here in the bottom, they're going to start with north. So they always start with an N or an S. Okay? Keep that in mind. Always start with an N, which is north, or an S, which is south. So again, all the S, N, N. So all of them are going to start either with an S or with a N. Okay, see it? Now the reason for that is that you always start measuring from north or south. Okay? Now these bearings that we have here, they don't have minutes and seconds. They only have degrees. So what it's doing is that, for example, on this one, let's say this one here, it's, well, not that one. Let's look at this one here. It's north 89 degrees, blah, 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 east. So it's north, an angle, east. Okay? North, angle, east. For example, this one is south, angle, east. And let's look over here, north, angle, west. Okay, so this is the direction that it's going, taking this into account. So this one is going, you always start from south or north again. So north, 45 degrees west, is that means that from north, you're going to go to west, which is on this side, 45 degrees. This one is north, 60 east, so that means that from north, you're going to go 60 degrees towards east. Okay, now if you have something, another line on this side, you're not going east, south. No, you always start from north and south. So in case for this line you have here, you go south 75 degrees east because it's going towards east. This line over here, it's going southwest 30 degrees. So it's south 30 degrees west. Okay, so if you see those bearings here, all of them are going to start with the north ONS, and that's what it's doing. From south, you're going to go 32 degrees, 57 minutes, 57 minutes, 52 seconds west. Okay, so let's look at that one. It will be more or less, it's south 32 west. So it will be south, okay, over here, 32 west. So that line will be somewhere above this one that's at 30. Okay, so again, you always start from north, south, and it goes in the direction that those letters that you have. And you're going to have two. South, east, and again, or northeast, north. It's going to be southeast, southwest, or northeast, northwest. That's going to be the combination you're going to have. And then the degrees in which that line is going to be at, or towards the other, either east or west, that's going to be the degrees, or the angle. Okay? Okay, hopefully that's easy to understand. And again, that's just the basics of it. And again, each property is going to have a bearing, which tells you exactly in real life where that line is going to be. Now, here you see minutes and seconds. This one, just for the purpose of explaining, it just gives degrees. Now, all of us know what a degree is, right? You start from, again, take this circle, 0, you start from here, it pulls up all the way to 90, and then it continues until it goes back to 360, which is a circle. All right, so each degree, it's going in, if you go in increments of 1 degree, you have a bunch of lines going in increments of 1 degree, correct? And you're going to have 360 lines all the way around because it's 360 degrees. But for the purpose of property, especially if the property is large, you have to be a lot more precise than just degrees. Okay, not just degrees. A degree, and if we actually look at it in front of us, if I get a paper or you get a paper, and you draw a line, straight line, from going from left to right, and then you pull it up a degree, it's very minimal. But now use your imagination and think now that those two lines that you drew on a sheet of paper, they're going to extend straight 40 miles. Okay, so remember, imagine those two lines, they extended 40 miles, or they extend, from where you're at, 40 miles away. So at the beginning, you won't see much of a difference in 1 degree, but once you get to the end of those lines, then the space between them is going to be larger. Okay, hopefully you can picture that. Or just take this, right? You see this hidden line there, and then you see this solid line there. Okay, that's 30 degrees from here to here. Why? Because that's 60, and then this is 90, that's 30. So imagine these lines. As we're close to the origin where they meet, the spacing between these lines is closest together, and it won't make much of a difference. But as these lines continue projecting away, the space or the angle becomes, not the angle becomes bigger, but it pulls them apart more and more and more. So again, imagine this one went 20 miles that way, this one went 20 miles that way. At the end of 20 miles, is going to be huge, the difference between one point to the other, or between one endpoint and the other endpoint. So that's why you have to be a lot more precise, not just in degrees. Imagine you buy a piece of property and it's, I don't know, 100 acres. And they only do it with degrees. At the end, when they start measuring from a point of beginning, which is what we're going to talk about next, from the point of beginning all the way to the end of those lines, you might be cutting into someone else's property, or you might be giving away some of your property to somebody else if you fence it. So that, in other words, you have to be more precise on the way you do degrees. Okay, so again, just if you think of degrees, they're very close to. I mean, 1 degree is very, 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 very close, but as it travels in distance, the spacing between the endpoints it's going to get bigger and bigger and bigger. So what do? That's when this come in. The minutes and seconds. Okay, not just degrees, minutes and seconds. And the way it is that for every degree, there's 60 minutes. And then for every minute, there's 60 seconds. So in other words, just imagine I wish I had opened, well, to show you guys here how what I'm talking about. Just imagine you have a degree. Okay, let's imagine. Okay, use your imagination. Let's imagine from this line, I'll put it down, from this line to this angle. Let's say it's not, but let's say it's a degree. It's 1 degree. Okay, again, it's not, but just bear with me. Imagine that from this line that goes from this point to E, that's that hidden line. Imagine it's straight, and it's a line straight, and then imagine this one going up. Again, imagine that from here, imagine that's only 1 degree. Okay, just so we can see it. It's a little bigger. So imagine this is 1 degree. So what a minute does to 1 degree, it cuts it into 60. It cuts that degree 60 times. In other words, there's 60 minutes in each degree. So imagine now it's like very minimal. The spacing equals, the increment of going up is not just in degrees, but each degree it's cut into 60 sections, which are the minutes. So now you're just cutting, the pieces are becoming, or the angles, or it's, in other words, the space between a line going straight and pulling up is very minimal now. It's not just 1 degree. Is in 1 degree you get 60 of them, or that degree cutting is being cut in 60 angles, if you want to call it like that. Okay, so now it's more precise. Now to each minute. So now imagine this is 1 degree. Only, again, use your imagination. This is 1 degree right here. You cut it into 60 times, and then you zoom a lot more, and now you get just the minute that you just cut. Just 1 minute, that it's 1/60th of a degree. Okay, if you can imagine how small that is. Now that minute, then it's cut into 60 sections, and that's a second. So very precise. Okay, so imagine a degree, how big that small that could be. Then you can cut that degree 60 times, which are the minutes, and then you're gonna grab one of those minutes and cut it again 60 times, and those are the seconds. So now it's gonna be very precise. So now going back to the thing that you bought all those acreage, and you do your bearing to degrees, minutes, and seconds. Now that line is gonna be very precise. Why? Because it's like you're splitting hairs on the way you set your bearing. So it's gonna be very precise. Okay. Hopefully you get the concept. If not, read the book and do some research. But again, once you get the idea, it's gonna make a lot of sense. So those are your bearings. You have to, they will start from north and south, and they either go southeast, southwest, or northeast or northwest, and then the numbers in between are degrees, minutes, and seconds. Again, for every degree you cut it 60 times, and those are the minutes. For every minute you cut it 60 times, and those are the seconds. So you can imagine how precise that is. Now, one more thing. The video is getting long, so I need to go a little bit faster. One more thing. From where do you start? Okay, so if you tell me, if I bring the site plan back, I say, whoa, I have all those things, but from where? Okay, from where am I starting? From where am I gonna base all those bearings from? Where do I put them? Well, that's where point of beginning comes in. And again, this I got it from online. I should have looked at it a little more closely. Control center, okay. Okay, I don't want to spend time looking for it, so I'm going to show you another sample. So in other words, you have to now tie it down to where is it that you're going to give that, or from where you're going to start your bearings. So now, upon the beginning, the book says it could be a tree, it could be something that's stable on the lot, or on the site or your property. But in our case, on our cases here, for every subdivision, a surveyor comes in, they do the plat, they let me show you this. They mark where the properties are. Okay, so some of these marks you see here are gonna be, when they develop an area, a developer comes in, they're gonna put those metal rods in the ground, or pins. Okay, so if you're curious, go to your house and more or less think where your property ends, and when the neighbor's property ends, go close to the street, maybe somewhere there. Not to the street, but if you have a sidewalk, maybe inside the sidewalk towards the inside of your property, and then more or less, if you kind of figure out more or less where you think your property starts and your neighbor's ends, and just excavate a little bit, you're pretty sure you're gonna find a pin, a metal pin. That's it was put there by the developer of the subdivision to distinguish where one property starts, where is the other one end, and those more or less are going to be these right here. Okay, so we're going to use that as a point of beginning. Let me show you this one here. See, here we have these other bearings. We have the degrees, minutes, and we have the length of that particular length of this line of property. But we need to tie down somewhere, and that's going to be a POB, point of beginning. Okay, so you need to find that, and then from there is where you start drawing your site or your property. Okay, just the property that you have. This is not the site plan. The house is going to be, or the building is going to be somewhere here. Right now we're just talking about where is our property. So we discussed on the angle and the precision of it. Okay, this right here is the length. But from where we're going to start, we have to start from a point of beginning. So for example, in this one, if we start from here, then this one is going north 40 degrees 0 minutes west. Okay, and then you continue. And actually I think it shows it here from POB. All right, this is like an explanation from POB, north 40 degrees west, and then the distance, and then south 56 degrees 45 minutes west, then the distance of that line, and then so on and so forth. So you just, from the point of beginning, you're telling it that from this, go up, from this point, which is the point of beginning, you start laying out your property. Okay, so it's very important to know exactly where is it that you're at, and you do that with a point of beginning. Okay, and again, more than likely, if you go and excavate some there on your property, you're gonna find some pins. And again, so if you, for example, you want to put a fence in your house, don't go off what the neighbor in front of you has. Look for those pins. So more than likely, if you hire someone to do a fence for you, they're gonna excavate, they're gonna look for that pin, and then from there, they're gonna look for the one in the back of your property, and they're gonna put a string so they know exactly where your property is. And I'm pretty sure you have seen this before. So that's what it means. Okay, they're trying to find out exactly where is your property. Or when you see a new construction, when they start working on the ground, either bringing dirt in or whatever they need to do on the property, before they even laid any foundation, they need to know where the property is. So they put some stakes on the property, but before they do that, they need to know where are the pins. So once they find that, they mark it. They put the points on the property so they know exactly where the property is. So they don't go past to the neighbor or give some of your property to the neighbor. So again, very important, the point of beginning, those are the pins there and there. And then based on that, you do your bearings, which is the angles, and then of course the distance of each of those lines, which are your property lines. And you see them here, these are your property lines. Okay, and if you want to start working on AutoCAD, these are going to be phantom, or the line type is called phantom, but that's a property line. So it's a long line, two smalls, one long, two smalls, and so on, and it continues. Okay, I'll stop it there, and then we'll continue with the next video.